Okay, this is the video recording for Pre-Calculus Unit 4, Lesson 4.4. Okay, so we're going to start talking about this thing called logarithms, right, or logs. We've kind of touched around the subject, and you might have heard it once or twice before, but we're really going to figure out what this is. So looking at what we've now learned about exponential functions, okay, here's a couple examples: population growth, savings account, radioactive decay. All right, so these are examples of exponential growth. Okay, and so we can write them as like, here's our equation. All right, but what we're going to need logs for is to be able to figure out, okay, well, what value of x is going to make this answer 200? Or what value of x is going to make this function true? Okay, so that's really the question here, is how do I undo an exponent when I have x as my value here? And we're going to read this thing called logs. Okay, so if we go into our study here for logarithms, okay, I'm not even going to read this joke here because they think it's funny, but basically it's about saying we need more population here. All right, so we'll watch this video here and go from there.
The joke involving Noah and the snakes is about logs, which is short for logarithms. In the end, you may not think the joke is funny, but you will be able to explain why it is supposed to be funny. What is a logarithm? A logarithm is just an exponent. This is worth repeating. A logarithm is an exponent. When you write y equals log base b of x, you are saying that y is the exponent to which you must raise b in order to get to x. Let's look at some examples.
Okay, so pause right there. It is just an exponent, right? So as we were saying earlier, like square root of x equals y, therefore y squared must equal x, right? It's just going forward and backwards. So if we're looking here at this reaction here, b to the power of y equals x, okay? Well, that means that y has to equal this thing called log b of x. All right, log b of x, right? It's saying the forward and the reverse reactions here.
What is the log base 3 of 9? To answer this question, ask yourself, to what exponent do we need to raise 3 in order to get to 9? The answer is log base 3 of 9 equals 2, because 3 squared equals 9. What is log base 2 of 8? To answer this question, we ask ourselves, to what exponent do we need to raise 2 in order to get to 8? The answer is log base 2 of 8 equals 3, because 2 to the third equals 8. What is log base 10 of 0.01? To answer this question, we ask ourselves, to what exponent do we need to raise 10 in order to get to 0.01? The answer is log base 10 of 0.01 equals negative 2, because 10 to the negative 2 equals 0.01.
Okay, so now if we look back here, all right, the joke here was that after the lands flooded, Noah told the animals, okay, go forth and multiply. Several months passed, Noah decides to check up on the animals. They're doing just fine except for a pair of snakes. He said, what's the problem? We need you to cut down some trees so we can live, says the snake. Noah follows their advice. Several more weeks pass. Noah checks on the snakes again. There are lots of little snakes. Everybody is happy. Noah asks, can you tell me how the trees helped? Certainly. We're adders, and we need logs to multiply. But ching. All right. So again, talking about how to move forward and backwards and understanding this equation. All right. So if we're looking here, log base 10 of blank equals 3. Log base 10 of blank equals 3. So if we look at this here, we can basically ask ourselves, okay, 10 raised to the third power is what? 10 raised to the third power is what? And the answer is 1,000. All right. Looking at this one, log blank 32 equals 5. Log blank 32 equals 5. This question is asking what raised to the fifth power is going to give us 32. Right? And the answer for that one is 2. Okay. Log 4 of 64. Log 4 of 64. So 4 raised to the what power is going to give us 64? That one is 3, right? 4 raised to the third power is 64. All right. log 3 equals 1. Or sorry, log 3 of 1 equals what? So this is saying 3 raised to the what power gives us 1. And the answer to that guy is 0, right? Anything raised to the power of 0 is going to give us an answer of 1. All right, and then finally here, 10 raised to the power of what is going to give us this decimal here? Okay, and the answer for this one is going to be -3. So if you plug into your calculator 10 raised to the power of -3, you're going to get out that decimal there. All right. So then here, there's two kinds of logs, right? There's this thing called common logarithm, and then there's this thing called natural logarithm. All right, so looking at it simply, a common logarithm is any logarithm with this thing called base 10. Base 10, right? So when we were saying log with that little lower number, right, we could say log base 3 of 26 equals 5, right? So let me go back to one of these problems here. Okay, this is saying log base 4 of 64. That's how you would read this. Log base 4 of 64, right? And we said that one was 3. Okay, so here we can read another one. This is saying log base 10 of 0.001. Okay, so this log base 10 is our common logarithms. Okay, that base 10. All right, and we used this system of tens a lot for our chemistry classes here. All right, but enough about that. Right, moving forward, that's our common logarithm scale. Okay, and a natural logarithm, we'll learn a little bit more about the differences here in this video. Okay, so sorting through the logs.
Common logarithms are logarithms that have the base 10. They therefore express numbers that are powers of 10. They are so common that people typically write them without including the base. When you see the term log x with no base indicated, you know that this is a common log, and the base is 10. Can you evaluate the common logs that you see here?
Okay, so again, if you ever see it, just log the 100, right? Assume that it's base 10, meaning 10 raised to the what power is going to give us 100, right? And that's 10 squared there, all right?
Natural logarithms are logarithms that have the base e. What is e? It is an irrational number that is approximately equal to 2.71828. It may seem unnatural to use an irrational number as a base, but it turns out that E is a number that is used in banking, population growth, and a wide range of other applications. You certainly will use E extensively when you get to calculus. You denote natural logarithms as ln, and read lnx as natural log of x.
Okay, so again, ln of x. So we'll talk more about this here, but I want to point out a couple quick things here. On your calculators, if you look at your calculators, all right, you will have a button that will say log. Okay, so if you look on the left-hand side of your buttons, right, you've got your on button in the bottom left-hand corner. If you go up 2, you see this ln. Okay, so that ln button is what's talking about right here, ln of x, which is your natural log of e. All right, and then the one above that is your log function, right? Your log function. And when it says log, if you hit enter on that, it'll only tell you log. Okay, and again, that's assuming we're doing common logs. So that would be log base 10. All right, that would be log base 10.
Your calculator most likely has a key labeled log and a key labeled ln.
Perfect. Those are the ones I just walked you through.
You can use these keys to calculate common logs and natural logs of any number greater than 0. If you have to find the logarithm using a base other than 10 or e, you're going to need some help. The following formula, called the change of base formula, makes it possible to use your calculator to find logarithms for any base. Look at the problem on the screen. You know that 5 to the second power is 25, and 5 to the third power is 125. So you can estimate that the exponent you want is somewhere between 2 and 3. But since your calculator does not have a key for log 5x, how will you find log 5 50 more precisely?
Okay, you would plug it into this equation here, right? You could plug it into this equation. So if I know that log 550, right, we're solving for that. So my 5 value is my b. So I would type in log base 10 of 50, right? Log base 10 of 50 divided by log base 10 of 5.
If you have to find the logarithm using using the change of base formula, you can write, using the common log as your new base, you use the log function on the calculator to find the answer. Alternately, you could write, try this and verify that you obtain the same answer using either the common log or the natural log.
Okay, and again, the reason it doesn't matter is because you're using the same base function. So up here we're using log base 10, and ln, remember, stands for log base e. So it really doesn't matter as long as it's the same one, but we have to do that change of base formula.
You should discover that log 550 is approximately 2.43, so that 5 to the power of 2.43 is approximately 50.
Okay. So again, we typically deal with our two main ones. So again, the log, which is our base 10, and our ln, which is our natural, which is our base e. Okay, there are other ones, obviously, like we said, log 5 of 50, or log base 5 of 50, but in order to do this, you have to use that change of base equation. All right, so changing bases here. All right, again, to write this out, you would have to use your change of base formula. So let me pull up my calculator and we can walk through some of these problems together. Okay, so looking at my calculator here on the right, okay, my calculator again is a lot more advanced, but that's what you kind of pay for here. So mine is a little bit more than what yours would see. You might just say log of 15 divided by log of 3, but mine also has that base 10 function. So when I hit enter, my answer should be 2.46. Right? My answer should be 2.46. Okay. When I do this one here, log base 5 of 35, so hopefully I can just copy and make this easy on us. Perfect. All right, log base 5 of 35. So I have 35 on top, and I have that 5 on bottom. All right, when I hit enter and solve, I get 2.2. Oh, sorry, 2.21. 2.21. And it looks like Apex is particular that they want 2 decimal places. So please make sure you put those 2 decimal places and don't mess up like I did. All right. Doing another problem here. Okay, so we can actually use the ln function just to prove that it works as well. So if we're looking at log 2 of 75, we can do our ln function instead of log here. So let's look at what that might look like. If I have ln of 75 over ln of 2, I hit answer and I get 6.22, or round that up, 6.23. Okay, and there's 2 more problems here, and I'll let you work through those on your own so that you can get some practice here. And just like everything that we've been doing, okay, there are a set of rules that go along with this particular type of function. So let's listen in here and figure out what the rules are for logarithms.
I still don't get the joke about the snakes needing logs to multiply. In an earlier study, you learned rules for multiplying and dividing exponential expressions when the bases are the same. Since a logarithm is just an exponent, it shouldn't surprise you to find related rules involving logarithms of products and quotients. Here is a summary of the rules needed for calculating with logarithms. The log of the product of 2 numbers is the sum of the logs of those numbers. The log of the quotient of 2 numbers is the difference of the logs of those numbers. The log of a number raised to a power is the power times the log of the number. Take a quick look back at the equivalent forms of the exponent rules that relate to these rules for logarithms. The first rule deals with the addition of exponents, or logs. The second deals with the subtraction of logs, and the third deals with the multiplication of logs. Oh, I get it. We are adders. We need logs. Here are two examples to show how these rules work. In this example, use the rules to calculate log 4 of the square root of 128. Start by writing the square root of 128 as 128 to the 1/2 power, so that you can use Rule 3. In the next step, use Rule 3. The log of 128 raised to the 1/2 power is 1/2 times the log of 128. Next, write 128 as 64 times 2 so that you can apply Rule 1. In this step, use Rule 1. The log of the product of two numbers is the sum of the logs of those numbers. You know that the log base 4 of 64 is 3, since 4 to the 3rd power equals 64, and log base 4 of 2 is 1/2, since 4 to the 1/2 power equals 2. Substitute these numbers into the equation. Finally, you do the arithmetic indicated and find that log base 4 of the square root of 128 equals 7/4. In the second example, you will combine several logarithmic expressions into a single logarithm. In the first step, you use Rule 3 to go backward and turn coefficients into exponents. Next, use Rule 1 to combine the first two terms. Finally, apply Rule 2 to produce the quotient as your final answer. Be sure that you do not make up your own rules for working with logarithms. For example, the log of x plus y is not equal to the log of x plus the log of y, and the log of x divided by the log of y is not the log of x divided by y.
Okay, so again, being really, really, really careful with, let me find it, paying attention to the rules here, okay? Paying attention to the rules, okay? They are different or slightly different than what we've seen for some of the other rules. So just being really careful with what those mean, okay? And again, this should be on your study sheet, so have this, write this down, put this somewhere, okay? This is going to be really helpful and important for you. So if I have log of two numbers, n, m times by n, that's an addition. M divided by n, that's a subtraction. M, p, that's going to be bringing the p out in front, all right? And then looking at these rules that we already know, okay, if I have a to the power of m times a to the power of n, that's added together, divided by is subtraction, okay, and then raised to the power of something else is multiplication, okay? So there is a lot of similarities here between exponents and logs, but it is different than some of the other things we've seen for quadratics. So just being careful and paying attention to those as you go. Okay, so matching the logs here, we got to match the logs here with what their equations will look like in their simplified form. Okay, rather than talk you through this one, because I know it seems very, very overwhelming, what I'm going to suggest for this one is that you sit down with the notes, and you sit down with this matching thing, and you try to really work through and match them up here, okay? But it's paying attention to what it means. So for example here, I have these two added together, and then they're subtracted by this last one here, all right? So one thing we can notice though is that what this is saying is I've got this 2 gets up there and is actually ln of x to the power of 2, right? Same thing, this 4 to the power of 4, so that quantity is to the power of 4 there, all right? So that's the first step. And then if I add these two together, so ln of 7 plus ln of x squared, okay? That's like saying ln of 7 times x squared. Well, that's 7x squared. And then this quantity gets divided by what's being subtracted. So this first one here matches up right there, all right? So again, paying attention to what the signs mean and what they have to do, okay? So again, maybe to walk you through one more here. All right, I bring this half power up, okay? So I bring this half power up. So I actually have 49 to the 1/2 power, or that's saying the square root of 49, all right? And the square root of 49. So that's 7. So this one is now log of 7. All right, and I have log of 11 plus log of 7, which means I multiply those two together. So that gives me log of 77. All right. Then that is divided by log of 3. So my final answer for that guy is right there. Again, it's just taking it a step at a time. All right. To maybe work through one more of these, okay, maybe work through one more of these. If we look here, all right, we have to piece these out part by part. So what you can notice here is that I'm going to have a minus log of z to the 4th. All right, I'm going to have a minus log of z to the 4th. But that 4, right, we don't write it as z to the 4th. We bring that 4 out. So this one's going to have a minus 4 log z. All right, so we're looking like we're here, minus 4 log z. All right, then these two have to get added together. So I'm going to have log of x squared plus log of y squared. All right, log of x plus log of y. Great, but as you notice, we got to bring those exponents out front. So this y cubed becomes 3 log of y. This x squared becomes 2 log of x, right? So we match those guys up there. All right, again, I'll leave the rest of those for you to work through with your rules here. Okay, so moving forward here with our study guide. All right, moving forward here with our study guide, looking at the answers to this guy. Again, this is going to be really, really crucially important for this unit because I know a lot of these rules can get confusing, especially with the logs and the ln's and powers and all that stuff. All right, so a logarithm is just an exponent. Okay, so y log b of x is the same thing as b to the y equals x. All right. So then knowing this, to what exponent or power do we need to raise 8 to get 64? That is a way of asking this question here. All right. So then we should be able to solve for these variables, understanding now that it is just a logarithmic relationship between the two. Okay. So then a common logarithm has a base 10 and a natural logarithm has a base e. Okay. And then your natural log is your ln. Sorry, I skipped one. Your natural log is your ln of x, and your base 10 of log is the one you'll see on your calculator where it just says log, right? So if it just says log, it's assumed to be base 10. All right, so then you have log versus ln buttons on your calculator. All right, then we can also use this change of base formula. All right, so if I have log of b of x and it's not one of the easy ones that we know, I can now take log of 10 or ln of e, right? So I can either take my log function or my ln function and I can write it as log of 10 over log of b. All right. So then moving forward here, this is just working through all those problems. And again, they were specific, so pay attention to that. 2 decimal places. Make sure you can round correctly. All right. And then these are the last things I want to focus on here. Those rules. Okay, those rules. You had m times n, which means you're adding them together when you separate it out. When you do division, you're subtracting. When it's raised to the power, you bring that power out in front. All right. And then noticing some common misconceptions. This is not the same thing as this. All right. That is not the same thing. We cannot do the addition like that. All right. And noticing that division is not the same thing as combining logs. Okay. So paying attention that is not something that we can do here. All right. And again, there's a lot of really good problems for you to work through, especially the matching problems. Okay, make sure that you go through and try those out.